So before we head straight into rendering this, let's talk a bit about what we could also do in order to mesh this or generate a foam volume out of these individual grain particles. And for that I want to head up to my distributed PopNet here, dive in there, and I want to work on those load slices. That's where my simulation is read back into my setup here. So let's just highlight this, or maybe the sprite first, and just go to maybe frame 72. So we see we have a simulation result here with all those individual grains here. And what I want to do now is turn those into a whole volume. So let's, for example, drop down a VDB from particles, wire this up here, and then in the VDB from particles, just dial down the voxel size to something rather small, 0.005. Again, that depends on the size of your grains here. And just highlight it. We can see we have now this VDB representation of our grains here. And then let's smooth this using a VDB smooth SDF. Wire this in here. And let's set the blur operation to Gaussian and run this only 2 iterations like that. Let's highlight it. And we are getting this rather foamy look of our volume by blurring those out. Let's maybe in the VDB from particles increase our point radius scale to say 1.25. So the size of those individual particles is expanded and the foam doesn't look as jagged as it is here. Well, maybe that's a bit too much. Let's try it like this. Yeah, that's a bit more to my liking. Let's check on a few other frames here. And maybe what I'd have to do is tweak my simulation a bit so I don't get those stray particles up here, which are just floating in midair, by maybe increasing the gravity a bit so they get pulled down. But for now, for setting this up, we will just leave it as it is and attach a null down here. Call this one out_VDB and wire in my VDB smooth here like that. And in order to execute this using PDG2, let's head back into our TopNet here. And I could feel tempted to just drop down a ROP geometry node here and wire this in directly here. However, as this ROP geometry here is set up to be a distributed sim, what it will generate is individual slices. While with this ROP geometry, I want to fetch my results for each frame that have been converted into VDBs. So what I want to do is basically I want to reassign those individual tasks here into whole frames. And for that, I'm going to use a partition by frame node, wire this in here, and this will take care of merging together those individual slices into their components for each frame, and then piping them down to this ROP geometry here, which in turn will point to the result of our VDB smooth node. So let's do that by selecting our distributed popsim and selecting the out_VDB like this. Just check on the rest of the settings here. That looks fine, and that does do. Let's just save this, and what I could do is, of course, execute this, have it run on the farm again. Let's just arrange those nodes here a bit better. So what we can see now is that these 961 individual tasks have been merged to 240 tasks by the partition by frame node, which are then piped to the ROP geometry, which now saves out our smooth volume that we generated out of those grains that we simulated. And again, what I could now do is tweak my simulation so I get rid of those stray particles here and then execute this whole TopNet in one go on the farm, and PDG will automatically find out which tasks here have been already finished, then partition them and then pipe them out to our VDB and directly save those resulting files. However, we wanted to talk about rendering. So let's stop this for now. Let's just ignore this error message for now. That's because we stopped it. And for rendering, instead of using that VDB, I will just use the grains directly and render them using Redshift, a third-party render engine. And for that, what I did is on my clients, or at least the 2 of them that have some sort of GPU in them, is I installed Houdini and HQ Client as I did on the other clients, but also installed Redshift just as you'd normally do with Houdini, by downloading the plugin, installing the plugin, and then modifying the houdini.env file to point to the right plugin directory. That's all I had to do on those clients. So let's set up some quick Redshift rendering by heading up one level and maybe adding a ground plane. Let's view this from the side like this. Just move the ground plane down a bit, maybe scale it up so it fills the frame. And then here, I'll go to my Redshift shelf, and I'm going to add a Redshift light dome for lighting, which I'll point to an HDR that's directly in my work folder. So I can, instead of pointing this to a direct folder path, just use the $hip syntax. I'll just switch off my grid here in the display, then add a camera by control clicking on that, and by clicking on the Redshift icon here, just adding my Redshift render nodes here, which I'll set up to do some sort of global illumination, just your basic brute force algorithm. Maybe increase the bounces to light the foam a bit better. And then under optimizations, I want to also increase my reflections, refractions, and my combined bounces to a really high value, so all of my foam pellets get lit correctly. Let's just close those tabs here and pin this one, and by hitting Ctrl T, open up 2 new tabs in here, one set to out, one set to material context, and one to OBJ. That's how I like to work. Let's save this for now and do a bit of shading here. So in the material, what I want to do is create 3 Redshift material builders, which I'll use to set up my materials. Call one foam, one torus and one BG for background. Let's start with the BG one first. That's going to be easy. In here, just dropping down a Redshift material, getting rid of the reflection and setting this color to, I don't know, maybe something along those lines, really dark, bluish red. Then for the torus, again, gonna drop down a material, and I'll be super lazy and just use the copper preset for now and dial in the roughness higher like this. Head up, and finally for the foam. This one is a tiny bit more involved, so I'll actually use a material blender to blend together two materials, and then drop down two materials. Just copy this, paste this here. One goes in the base color, the other one in the layer color. And for the base layer, what I want to do is first I want to set my diffuse to all white, but dial back its weight to 0.1. And then increase the translucency to 1, set it to all white 2. And under the overall tab, I want to set my opacity to be 0.75 like this. And in the advanced tab, I want to give this a bit more diffuse and indirect scale, so it appears a bit brighter, 1.5 like this. The second material starts off pretty similar, so dial back the diffuse to 0 and increase the translucency to all white and a weight of 1. But then the reflection, let's just dial that back to 0.5 and the roughness to 0.52 and set the Fresnel type to the color and edge tint and tint both to all white like this. What I want to do in the overall tab here, I want to drive the opacity with a Fresnel so that the opacity depends on which angle we look at the individual spheres. So let's wire this in the opacity color and uncheck use index of refraction. Instead, we're going to use the curve fall off and set the facing color to be 0.2 like this, gray here, and the perpendicular color to be 1. Now, finally in the material blender, let's dial in this layer's blend color here to be 50%, 0.5 like this. And that should be it for the foam. Let's just save this, and in the OBJ tab assign our individual materials. So the distributed pop object, let's just highlight our sprites here for rendering, just skip to a frame where we actually have some simulation. Head up again, and on this note, on the Redshift OBJ tab, I want to go to particles, check render object as particles, and on the render tab, just assign the material, the foam material. Let's do the same thing for our collider here. I'll just attach a subdivide here to increase the resolution of this, the mesh resolution like this, and maybe an extrude too to give this a bit of thickness. So let's use a poly extrude for that. Let's have a distance of 0.01, and also let's check output back. In the render tab, again, assign the material. It's going to be the torus, and then finally the grid. We'll get the background material like this. Let's just save this, and let's maybe dial this in a bit using our render view here. Let's head to the materials tab and give the torus a bit more color by dialing in the reflectivity and metal edge tint colors here. So let's just increase their saturation and maybe dial back their hue. So we get this reddish metal here, a bit like that. I like that way better. The rest works fine for me now, so let's try putting that on our farm using PDG. Just stop this, save it. So we set up our shading here, and in the top net, I'm just going to drop down a ROP fetch node here. I'm going to wire that in the partition by frame. So instead of saving out the VDBs here, I'll just render what I have here. I want to point this to my Redshift ROP. That's the ROP, not the IPR. Let's set this to evaluate using frame range. That's looking fine so far. Let's just check in the out tab in the Redshift ROP that we have set up render frame range and output to the file name that we want. Also having unchecked skip rendered frames like this. Okay, that's looking good. So back to our topnet and finally set up our rendering in our HQ scheduler. That is because we cannot use all of our farm for rendering this because I only have 2 GPU machines. So what I want to do is head to job parms here and under assign to clients, check listed clients. And in here I want to select 2 clients, which is the GPU here and this Dexter's lab PC. Both have GPUs in them and Redshift installed. So let's hit accept here, save this, keep our fingers crossed, and let's just cook this node, the ROP fetch, by hitting Shift and V. Alright, this clearly did not work as expected because I'm getting 600,000 render jobs here, so let's cancel this, Shift and D. And I just realized that in here I just made a mistake. So when I pipe in my jobs through this partition by frame here, I will have to set my frame range to single frame. So for each of those tasks here, I will start a single render job on a single frame, otherwise my render times would escalate. But what I could do is run this independently of my PDG network by just slashing this connection here, then set it to frame range. That would evaluate correctly, just pointing towards my Redshift drop and just starting a render job on my farm with my current settings. Or if I want to do this within my topnet here, just wire this up and set this to single frame. So whatever you choose, just keep that in mind. For now, what I'll do is I'll just slash this connection and set this to render a frame range. So you can just basically use your PDG as a render submitter to your farm. Let's just save this, keep our fingers crossed, and hit Shift and V and cook this. 240 jobs, that's looking fine. So let's have a look at this on our farm. And this is my browser, and we can see we have our job running here. And when I click on the job, I can see I've got my 2 clients assigned, Dexter's Lab and Ike's GPU 08. So that is running. And that is basically how you use PDG in conjunction with any third-party render engine. Basically what you have to do is just install Houdini normally on your clients and make sure you also install the HQ client, and then just install your third-party render engine as you'd normally do with Houdini. And finally, using your rob fetch, point that to your render engine's output node, and have your farm do the heavy lifting for you. So that is basic third-party rendering using Redshift and PDG.